Hello, and today's lesson is going to be on mass and force. Mass is defined as a measure of how much matter is in an object. Mass is commonly measured by how much something weighs, but weight can change depending on where you are, while the mass stays the same. So weight will change depending on your surroundings due to the gravitational constant of that planet or area. However, the mass will always stay constant. So the mass here on Earth, or the mass on the Moon, and the mass of Jupiter will always be a constant value. What will change is the weight due to the gravitational constant on that planet. So let's have a look at the following question. If an object has a mass of 50 kilograms on Earth, in space its mass would be, and the answer should be 50 kilograms, because the weight can change depending on where you are due to the gravitational constant. However, the mass will stay the same. Now, mass is used in two particular formulas related to force, and force is defined as measured by its effects. Force is used to move stationary objects or change the speed of objects already moving. Therefore, there are two formulas we need to consider. Force equals mass times acceleration, and force equals mass times gravity. Remember that gravity has a constant acceleration of 9.81 meters per second squared. So let's have a look at the following examples to see which one we would use. So the first example says a load of 50 kilograms has a force of 25 newtons applied. What is the acceleration of the load? So when you're looking at which formula to use, especially in this instance, we need to find a formula that has both force, mass and acceleration. So the formula I'm going to use is that. Now the formula that's in front of us will work out force. However, we can transpose the formula to find acceleration. So to find out an unknown quantity, in this instance acceleration, mass has to be moved from the right hand side of the equal sign to the left hand side of the equal sign. As mass is multiplied by acceleration, we can move the mass from the right hand side of the equal sign to the left hand side of the equal sign, and it will become a division. This leaves us with a formula: force divided by mass will give us the acceleration. We substitute the unknown quantities of force and mass, 25 newtons, 50 kilograms, which gives us an answer of 0.5 meters per second squared. Here's another example of using another force formula. In this instance, we want to find the force. However, the term that they use that allows us to use the formula shown is Earth. Therefore, the acceleration will be due to the gravity, constant gravity. So 9.5 kilograms multiplied by 9.81 meters per second squared gives us 93.2 newtons. Let's have a look at another example. In this instance, a mass exerts a force of 30 newtons on Earth. What is its mass? So in this question, we're looking for a formula that has mass, force and gravity, because it says on the planet Earth, and planet Earth has a gravitational constant of 9.81 meters per second squared. So here is our formula we're going to use. We're looking for the mass, and again, mass is multiplied by gravity. Now if we want to find the unknown quantity of mass, gravity needs to move from the right hand side of the equal sign to the left hand side. And as it's a multiplication with mass, it needs to move to the other side of the equal sign and become a division, as shown here. Now we put in the unknown quantities of force and gravity. 30, 9.81, that gives us an answer of 3.058 kilograms. Just be aware that we're working out mass, therefore the unit for mass is kilograms and not newtons, which is shown in B. Thanks a lot.